Go to TAPgiles.com to learn dreams, engage my services, and support the channel. So with a dot product, if we have a vector, so that's our vector, and we have another vector over here, and we'll make that green. One way to think about dot product is we start off with like a reference vector with the red one, and then you imagine a graph coming over here. So this is like a special graph that doesn't really exist. It's just like how this experiences the world. And now we look at this new vector and we kind of imagine it being in this world and see how it's kind of affected. So we have this position up here and we kind of drop it down to there, and then we look at how wide that is. So it's kind of like if this was in the graph world of this red arrow, how far along would it get? So in this case, it only gets like 0.8 of the way through. And then that's multiplied by the length of the red arrow. However, you can also think of these things, they don't have to be flat like this. They could be pointing in any direction. And you'd still have a graph that matches the reference arrow and meets the green arrow. So what happens if we like have this pointing up like that? The graph would kind of rotate to match it around this kind of origin spot. To be clear, like none of this graph stuff is really happening behind the scenes. It's not saying, oh, let's calculate a graph that meets that point and that point and that point, the origin point, and then scale the graph to one of the arrows and all this kind of stuff. This is just a way of understanding what it gives you out of the other side. So there is no trajectory it's actually doing. There's no angles. There's no nothing. The actual maths it's doing is very simple, but the output of the maths is like the thing that is trickier to get your head around. Kind of like that. So the grid just kind of conforms to kind of matching those two and kind of going through both the vectors as if these were just drawn on a 2D bit of paper, as if it was just flat like that. And then it drops that line and sees how far through it gets the kind of X on that graph. And it would be like there. Yeah. So it still gets through it only 0.8. So these things can be any like angle or direction, and it will still work the same. It will like compare these two arrows. But it doesn't actually matter which way round they go, because if you think of it as this being the reference, then it would just be the same graph kind of rotated round like that. And then you could like rotate it around like that so it's flat. And then you draw a line down and see how far through this red arrow gets through that. And it still only gets 0.8 of the way through. So one of the arrows defines the orientation and size and shape of the grid, and then this is put onto the grid and where is the X. So you can do stuff like, if these are normalized and their lengths are 1, if this arrow was parallel to the reference one, then it would give you 1 because they're the same length. If we as we rotate towards 90 degrees, this is getting less and less because it's covering less of the length of that arrow. And when it's pointing up, it's pointing 90 degrees around. Now it's giving you 0 because it's got like none of this is covered by the arrow. Then you keep going and it gets negative because it's going, if you drop a line down there on that graph, you're in the negatives now because that's the 0, that's the positive, and that's the negative. And it gets more and more negative until it gets to 1, and then back round to 0, and then 1 again. In the way you'd probably use it, you can also think of it as how similar are these arrows? Is it very similar? Is it diametrically opposed? Is it just not similar at all? they're pointing in perpendicular directions. So you can have like, that might score you 0.5, and that'll give you 0.5, and that'll give you 0.5, like around this whole cone. So it's kind of similar to the way an angle sensor works with this cone. So like, so if you did that kind of thing, that would give you kind of the one vector would be this reference vector, this one pointing up, and then the green one would be this one representing the up arrow of the box. And then it's giving you like, if you look up here, it's giving you basically the dot product. So like 100%, and then it goes down, so it gets to 0%. And then down here it would go to negative.
Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.